Hello class, this is a walkthrough of our week 2 chapter 2 practice it problems. We're going to be getting into a little bit more complicated stuff this week, so I wanted to go over it with you. So I've got these 1, 2, 3, 4, 5, 6, 7, 8 of the self-checks and then 2 of the exercises. So let's go through it. So here is the first one. I'm not going to do any of the ones that I've assigned to you. I'm just going to walk through it, but I'm going to try to do other ones that are not assigned but I think are relevant. So first of all, what are the legal literals? So you need to understand what forms an integer versus a floating point versus a string. Pretty straightforward. Okay, we're going to skip. So 2.2, you're going to have to do this one as well. Remember the old PEMDAS rules. Parentheses, there are no exponents here, but then multiplication and division, then addition and subtraction. Remember the mod operator here is basically the same precedence as division. So you need to understand what those rules are, and we're going to give you some more work in this one here, self-check 3. There's a lot of these, and when you submit, it will tell you some information, but it may still be frustrating. Many of you may even not be able to get them all. Do your best here. Even if you don't get them all perfectly, I will see what you submit. But I will warn you that absolutely no students at the end of the last quarter's final got 100% of these types of problems right, which is really a shame because you're losing points on a very simple topic, and you really should be able to get 100% of these right the first time. And if you don't just skip over this thinking, oh, whatever, that's just 1 point. No, this is going to be on your next quiz. This is going to be on your final, okay? So take the time to understand it. I'm going to show you a couple examples right now here. I've actually worked a little bit on these, but I'm going to get rid of these and we'll go through these together. Okay. So these are similar, but not exactly the same. But they're actually a little bit more complicated. So remember the PEMDAS rules, parentheses, there's no parentheses, there's no exponents here, but we do have multiplication and division happen first. So here we've got a division, we've got a multiplication, we've got a division. So these are all going to be performed at the same precedence left to right. These ones here, we've got multiplication, we've got division, but there's addition and subtraction, well, just addition in between. So they're gonna happen piecewise. This group, then this group, then this group, then perform this addition, then perform this addition. So let's go ahead and do this. Now, the complication with computers is that we need to understand which of these is a floating point, obviously the 4.0, and which is an integer. If Java is faced with operating on a floating point and an integer, it will automatically convert. So it'll result in doing 4.0 divided by 2.0. So that's going to be not 2, but the temporary answer is actually going to be 2.0. That's the first part. Then, then we've got multiplied by 9, but because we've got a floating point on one side, it automatically converts this to a floating point. So that's going to be 18, and then divided by 0.0 again, then divided by, again, it's going to be a floating point 2.0. So the result is not going to be 9, but 9.0. Here we do the same types of things. Here we generate a floating point 5.0 plus, then here these become floating point. So 8 divided by 5 is 1.6. So that becomes 1.6 plus, and then a 10 divided by 3. Now both of these are actually integers, and so Java does not need to convert these to a floating point regardless of what happened over here. It's a completely separate story, okay? So Java will evaluate this as 3, okay, because that's the integer division, the truncated integer division. 10 divided by 3 would be 3.3, but because they're both integers, we just truncate it to be an integer, 3. So now we go back and we take a look at the addition. So this is going to create 6.6 plus 3. Now ask yourself, is this going to be a floating point or integer addition? And because one of them is floating point, the other one will automatically become floating point. So that's going to be 9.6 floating point. I wanted to jump down and show you one with mod here. So 813 mod 100. Now we all know what dividing by 100 would do. 813 divided by 100 would give us 8 point something. integer division, if this were just a divide, it would result in just 8, okay? But the mod gives us the remainder. So 813 divided by 100 would be 8. The remainder being 13. So the result of that is 13. It's not a floating point because these are both integers and mod is an integer operation anyways. So we got 13 divided by 3, and so it's still an integer. So 13 divided by 3, we know that that's going to be 4 point something, but because it's an integer division, we just have 4 plus 2.4. Now, only at this point do we treat this as a 4.0 because we've got both sides. One side is a floating point. So the result is going to be 6.4. So let me just hit submit on these three. And so we see the three that I attempted are all correct. So that's just, let me go back and show you three. So you've got the same kind of things here. You've got parentheses, remember, go first. There's no exponents. Multiplication, division, okay, remember mod is going to be a division, an integer division. So it's challenging. It's much more challenging than you think, but it's very important that you be able to do 100% of these correct the first time. Okay, let's go on to number, oh, here I want to show you one back here. So there's also precedence with strings, and the rules with strings are a little bit different than what you might think. So, for example, right here, the result of 2 plus 2 makes 4, plus 3 makes 7, plus 4 is 11, okay? This is a totally different beast because it's got 2 plus 2 space, okay? That is a string. When Java takes a string and a non-string, it will actually convert the non-string to a string. So it's just like the floating point rules, but it's slightly different. So this becomes the string 3. And then the plus is actually a concatenation. So this becomes that. Okay, that's not what you're expecting, is it? And then same with the 4. 4 is just converted to a string and concatenated. So that is the result. What's the next one? We get 2 plus the string space 2 plus 3 space. Okay, so how do we treat this? By those same rules, we have to convert this to the string 2. And this plus becomes a concatenation. So it concatenates that to the front. And then this plus 4, that just converts 4 to a string. And this is what we get. So let's try submitting these. So those three that I attempted are correct. All right, so that's string manipulations. Okay, so that's number 5. Okay, so 6 you're going to have to do. It's very simple. I just want to make sure you understand how to define things. Okay, we're going to skip over to 9. So 9. So remember the work that I showed you on mod 813 mod 100 gives you the remainder of that division, which is 13. So now we have an integer variable called number. So we know it has, this expression is going to be something to do with number. What Java expression produces the last digit of the number? Okay, so we figured out if you have a 3-digit number and you mod it by 100, okay, what that'll do is give you the last 2 digits. But here they want you to find out just the last digit. So 813, how do you get 3 out of that using mod and div? Okay, so think about that. It's not very hard. It's a pretty simple expression. Okay, so let's move on. But it's very important because, again, all the way up through the final, you're going to be using mod over and over again. You need to understand not only how to use mod, but also why and where do you use mod, okay? Whenever you're trying to extract a digit, you're going to be using mod, okay? Whenever you're trying to find if something's odd or even, you're going to be using mod. Try to understand why that is, and if you don't understand, then ask questions. Okay, number 10. Okay, so here you're given some buggy code and you want it to fix it to print this out. What the main thing I'm going to tell you is you could just replace this string to say x is 0. That's not what they want you to do, okay? They do want you to have an integer x variable and an integer y variable here. So they gave you the integer x fine here. Now you have to fix that. You need to put some sort of statement in here to fix it so that when it prints out x here, it will be 0, okay? Because right now, those of you who are clever notice that nobody ever defined what x was. Okay, so down here, you want to print x is now 15. So this is not going to print that. So you need to do a couple of things. There's very possibly an error in here that you need to fix, but we do want to use x as an integer, and we want to assign it the value of the integer value of 15. So think about what you need to do to this line to set value 15, not 15.2. And then how do we print it out here? What do you have to do to this println statement in order to get to print the value of x? And then similarly here, they declare a y, which you do want, okay, and then it tries to do this here, which is probably not going to work very well. You need to figure out what do you replace this with in order for y to be 16, and how do you change this so that it prints that out correctly. Okay, so let's leave this page. Let's go on. We're going to skip way ahead to 22. Okay, so 22 is an important one for your homework assignment. Actually, sorry, 23 is the important one for your homework assignment, but I'm going to show you, I'm not going to do this one for you, I'm going to show you instead 22. Okay, and the book covers this very well. It's a little bit of a complicated topic, it's very simple, but you probably haven't done it as logically as it's going to ask you to do it here. So what you have to do is you have a loop value. Okay, so if you have a for loop for row equals 1 to 6, or actually this goes on past 6, okay, then you need to have a loop variable expression that generates this sequence. In this case, 2 times count would be the correct expression. Let's see if I can quickly do this. All right, I've got Eclipse set up on the other window here. I took my hello world and I just replaced the guts here with a simple for loop from 1 to 6, printing out row. Okay, and so let's see, what we want is this here. I'm going to copy that, put it over here. Okay, that's what we want. When we run it now, what we get is 1, 2, 3, 4, 5, 6. Okay, so what we have to do is we have to figure out what do we have to do to the variable row to get it to print 2, 4, 6, 8, 10, 12 in the format of a number times the counter plus another number. Okay, so we're going to have x times row plus y. Now this is a very simple example here. All we have to do is we take a look at the output. We see that it's increasing. Okay, so that means this number is going to be positive, and we see that it's increasing by 2. So we just put 2 there, and then we see, do we need an offset here? It starts at 2, 4, 6. No, we don't need an offset. So all we need is 2 plus row, just like it says here. They're using count. I guess I should have done count for consistency here. Let's do count. And there's actually an Eclipse function to change these for you, but I'm just going to show you that for now. Okay, 2, 4, 6, 8, 10, 12. Let me bring this up by just a little bit. So that's the simple one. Okay, let's try the next one. So now the same thing. We want to go 4, 19, blah, 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 blah. Okay, so remember we're going to have some sort of x times count plus y. Okay, first we look, are they increasing? Yes. Okay, so that means x is positive. Second, what is the difference between these two numbers? That's 15 there, that's 15, that's 15. So I know I'm going to have a 15 times, and then I have to figure out, do I have to offset? So count times 15 is going to start out with 15. That's too high. I need to reduce it from 15 down to 4. So that means I'm going to have to subtract 11. Okay, so let's run that. And so now 4, 19, yep, that looks right. So what we wanted here then is going to be 15 times count minus 11. Okay, now let's go to the next one here. Okay, so let's go back to the form, some x and some y. So first of all, are they increasing or decreasing? Now we see that they're decreasing. Okay, so we know that x is going to be negative. And we know, well, let's see how much are they decreasing. They're decreasing by 10, 10, 10, 10. Okay, so we're going to subtract 10 for every one of these. And then we have to see is there an offset. So when count is 1, you've got negative 10. So what do we have to put here? Minus 10 to equal 30? Well, that's going to be 40 from basic algebra. So let's try running that. And let me always save resources before launching. 3020 down to -10. So we got it. Okay, so we'll copy that. Okay, let's do another one here. Okay, so we see that it starts out negative values. It's actually increasing. Okay, so we know this is going to be positive, and it's increasing by 4. So we put 4 there. When count is 1, that's going to be 4 plus something is equal to -7. So what's that going to have to be? That's going to have to be -11, actually. So or -11. So 11 minus 4 is 7. 11 minus 4 times 2 is 8. Is oh, that's going the wrong way. So what we want to do, 4 times count minus, no, that's right. Okay, so 8, 4, count is 2, that would be 8. 8 minus 11 is -3. Yeah, okay, so this is working right. And then I always like to check the last one. So 1, 2, 3, 4, 5, 6. Okay, 6 times 4 is 24. 24 minus 11, the 13. Yeah, okay. Hit run. Ba-boom, that looks good. So hopefully by now you're starting to get a feeling for how this works. Let's go do the last one just for complete, to do it completely. So you know how to do these all. Okay, so are they increasing or decreasing? 97, 95, they're actually decreasing. So we know it's going to be a negative. How much are they decreasing by? Looks like 3. So -3. When count is 1, we've got -3. So what -3 is 97? That's going to be 100. And when count is 2, that's 100 minus 6, so it's 94. And when count is 6, so that's going to be -18. So 100 minus 18, yep. And that's right. So let's go put this in there. And let's go check. We passed all 4. Okay, so the problem that you're being asked to do is 23. So you don't have the little table like they were showing here before, but it's the same thing. Are they increasing or are they decreasing? Okay, if it's increasing, you know that the expression is going to be positive times, well, they use I. I hate using I. It should be a row. And then by how much? So -4 to 14 is figure out the delta there. Figure out the delta there, figure out the delta there. Then plug in when rho is equal to 1, what is your value and what do you need to offset it by to get -4? Okay, so that's 23. Let's go up to 30. Okay, so you got 3 nested loops here. Actually, 31 is the one that you guys are doing. You got 3 nested loops here. I'm not going to show you how to do this one, but it's it's somewhat similar to this one back here. We've got actually 2 nested loops here. So what I see here is I've got from 1 to 10, I've got this, and it's ending in a println. So I know that I've got 10 lines that is printing out. And then I've got this loop here separate from this loop. Yours, there's actually a nesting. But it looks like here, when I is equal to 1, it's going to be from 1 to 9. When I is 2, it's going to be J is from 1 to 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, followed by J is equal to, when I is equal to 1, that's 1, 2, 2 minus 1, 1. So it's just going to print out 1 star, then followed by a println. So when J is 2, I got 1, 2, 3, 4, 5, 6, 7, 8 spaces, followed by how many stars? Well, when I is 2, that means 2 times 2 is 4, minus 1 is 3. So I got 3 stars. And then the next one, 1, 2, 3, 4, 5, 6, 7 stars, followed by, it looks like it's going to be 5 stars. I think you can get an idea of where this is going to go. So that is 30. 31, the one you're going to do, so you've got an outer loop. Okay, that outer loop is doing something, followed by a println. Okay, you've got a middle loop, which is going from 1 to 3, and then you've got an innermost loop of 1 to 4. So these are fixed. That's actually easier to do than the one I just did. Okay, figure out what that output is going to be. All right, so that's 31. Now let's go to the exercises. Okay, so the exercise you're going to be doing is 5. Okay, see, that's it. You want to generate this picture here, And then number 8 here. Okay, now notice that we've got spaces leading before these numbers. I'm not going to do 5 or 8, but I am going to do a couple of others. And these are important because you really need to master doing these loops. Those of you who don't master the loops, it's going to cause you pain for coming homeworks, it's going to cause you pain for coming quizzes, and it's going to cause you pain for the final. So you really need to master this. So I'm going to go through a couple of different ones here. So and I think this is just bare code, so we don't need a full class. For int row equal to 1, row less than or equal to 5. So when you're doing for loops, you basically have two choices. Do you want to do it from 1 or from 0? If you're not doing something that's 0-based, like using arrays, always just go ahead and start from 1. It's a lot simpler, okay? So it could be from 1 less than or equal to 5, or 0 less than, just plain less than 5, 0, 1, 2, 3, 4. But I'd always recommend doing it from 1, okay? And then for int call, always use an intelligently named variable. If you just use I and j, you're going to get confused eventually. Out in the real world in Microsoft, we always use intelligently named variables. We actually use a convention that's called Hungarian, and it lets, I'm not going to go through the whole thing, but Hungarian pretty much ensures that we're going to use our variables correctly, because it includes not only the name of what it is, but also includes the type. It's pretty impressive. So for int call is equal to 1, call is less than or equal to, okay, actually, sorry, there's only 4 rows here, okay, 4 rows, and then columns, there's going to be 5 columns, and then I don't actually need brackets if I only have one statement here, and so I'm going to do system out dot print. Now I'm not going to do the println because I don't want to. We'll only want to do the println after it's done all 5 of these here. Okay, so I got 4 rows, 5 columns, printing out stars. After each row, column all the 5 stars, then I'm going to print out a new println. Okay, so that's correct. So I'm going to skip over the one that you're doing, 5, and go to 6. Okay, this was actually a much harder one here. You're going to be doing, let's take a quick look, 8. Okay, so you've got spaces and you've got numbers. Okay, so let's skip over 5. You're going to be doing that. 6. All right. So bare code again. So let's do row is equal to 1. And how many rows do we have? We have 7 rows, right? So row is less than or equal to 7. Row plus plus. Okay, now columns here. So I don't need any leading spaces on this, but for int call equals 1. Now I don't have a fixed number of columns. The columns are actually increasing. They're increasing once every row. So why don't I just use row? So for column is equal to 1, while column is less than or equal to row. So on the first row, it's only going to print out 1 column. On the second row, it'll print out 2 columns, etc. Call plus plus. Okay, so now I need a system.out.print, not lin. And now what am I going to print? Before I was like printing out a star, but here I'm actually going to print out the number. Which number? The row. So how do I get that? I've already got that variable right there. Okay, so that's going to print out a bunch of numbers for each row, and then I need to follow that with the system.out.println. Okay. Let's see if I've captured this here correctly. So just to, well, go ahead and submit first. Okay, so it passed. And so just to remind us, so we did 7 rows, okay, 1, 2, 3, 4, 5, 6, 7. If there were 100 rows, I would just use 100. For the columns, okay, the next problem I'm going to actually have to put spaces first, but I don't have to do that here. I'm going to go from column, I'm using from 1 to the number of rows. So in the 7th row, I have 7 columns. Now what would happen if I wanted to do differently? Instead of 1, 2, 3, 4, 5, 6, 7. What happens if I wanted to print out 3, 4, 5, 6, 7, 8, 9, 10 things here? I just have to add 3 more. Let's see. This is not going to work, but it's going to show you. See, it's going to print out 3, 4, 5, 6, 7, 8, 9, 10. Okay? And, you know, we've gone through this training here to figure out how do I figure out almost any arbitrary number. Okay? I could turn this upside down. I could print 7 1s and then 6 2s. How do I do that? Well, okay, so the first one is going to be, it's actually going to be decreasing, right? It's going to be decreasing. It's going to decrease by 1 each time, and then I have to offset it by, so if row is 1, and I wanted to produce 7 of those 1s, I need to do 8 minus 1 is 7. And then when row is 2, it's going to produce 6 2s. Let's try and see what happens there. Okay, so I turned it upside down. So look at the shape of that. What happens if I want to turn it upside down and actually print 7, 6, 5, 4, 3, 2, 1? Okay, so now instead of printing row, what do I need? I need to print, so instead of 1, I need 7. So that's going to be 8 minus 1 is 7. And then when row becomes 7, 8 minus 7 is 1. There, we turned it upside down and went from 7 down to 1. Okay, let's go take a look at 7. Here's another one. Okay, so this one actually requires spaces. It's a little bit more complicated. So for row is equal to 1, row is less than or equal to, how many rows I got? I got 5 rows. Row plus plus. For int, oops, I forgot the int. Column is equal to, okay, so first, comment, print spaces, followed by, okay, well, finish this up first. For columns equal to 1, columns less than equal, I'm just going to leave that blank for a moment. And what am I going to do in here? I'm going to print, not lin, but print space, followed by a system.out.println, finish my row. But before that, I got to print a single number. Okay, so I don't need a for loop here. All I need is a system.out.print. And what's the number here? So this is the row going from 1 to 5. So I just have to put row there. Okay, so let's try running this. Okay, I just got to, oh yeah, I got to go back and fix this. Okay, so what is the columns here? Okay, so on first row, well, we can see, I wish I could, I'd have to copy and paste this, but we can see there's 0 spaces here, and there's 1, 2, 3, 4 spaces here. Okay, so it's 4, 4, 3, 2, 1, 0. Okay, so we know that so first of all, it's decreasing, so we know it's going to be minus row minus something times row, and it's decreasing by 1, so it's just 1 time, so we don't have to put anything else there. And then we need to have an offset here. So when row is 1, we want 4. So what's that? This got to be, it's got to be 5 minus 1 would be 4. And then when row is 5, then it's 5 minus 5, which is 0. So that sounds about right. So let's go back. Submit. Okay, so we're very close. We see we've got expected output and your output. Okay, so problem is that we hit 0 too soon. So our offset's wrong. So when row is equal to 1, I guess I just am not counting enough spaces there. Yeah, okay. So it's actually got 5 spaces. If I had copied and pasted, I would have been able to see exactly. 5, 4, 3, 2, 1 is what we wanted. Okay, and that gives us this expression here. All right, so this process of going from this to this is very important. And I want you to start documenting. So 5, 4, 3, 2, 1. So row is equal to 1, 2, 3, 4, 5. print spaces 5, 4, 3, 2, 1. That gives us a row expression of negative row plus 6. Okay, that is important. All right, so that's number 7. And yeah, so the last one I'm not going to do. That's actually the one that you need to do. But you can see it's very similar. You have to have a certain number of spaces. Okay, you got numbers here. All right, so that is the walkthrough on your PracticeIt. You've got those simple self-checks, and then you've got these exercises here. And just like last week, you are just going to submit it on PracticeIt, and that's all you need. So good luck to you.